Hello everyone, welcome back to Coding Theory Guru. In today's video, we are going to do a deep dive explanation of the COCOMO model in software engineering. Okay, first is introduction. COCOMO stands for Constructive Cost Model. It was proposed by Barry Boehm in 1981. It is one of the most popular software cost estimation models. The main goal of COCOMO model is to estimate the effort, cost, and development time required for building a software project. Okay, so COCOMO stands for Constructive Cost Model. It was proposed by Barry Boehm in 1981. Okay, and it is one of the most widely used software cost estimation models. Okay, so the main purpose of COCOMO is to estimate the effort, cost, and development time required for building a software project. Okay, so why COCOMO is needed? See, in software project, cost and effort estimation is very important. Without proper estimation, projects may run out of budget, miss deadlines, or fail. COCOMO gives a mathematical way to estimate the size, effort, cost, and time of the software project. See, why do we need COCOMO? In software projects, estimation is very important. Okay, so without proper estimation, projects can easily go over budget, miss deadlines, or even fail completely. So the COCOMO models give us a mathematical way to calculate the effort, cost, and time needed for a project. Okay, parameters of COCOMO. COCOMO uses LOC, lines of code, size of the software. Effort measured in person months, PM. Development time, TDEV, measured in months. Cost drivers, attributes like team experience, tools, hardware, etc. See, parameters of COCOMO. First is lines of code, LOC. These represent the size of the software. Okay, then effort measured in person months, which means how many people and how many months are required. Okay, then development time, TDEV, the total time in months to complete the project. Then cost drivers, factors like experience, tools used, or hardware requirements. Then basic COCOMO equation. The main equation is effort PM equal to a multiply by KLOC raised to the power B. Okay, then TDEV months equal to C multiply by effort raised to the power D, where KLOC equal to thousands of delivered lines of code, A, B, C, D equal to constants depend on project type. Okay, so here KLOC means thousands of line of code and A, B, C, D are constants that depend on the type of project. Okay, types of projects in COCOMO. COCOMO divides projects into three categories. First one is organic projects, small and simple projects. Teams are experienced. Example, student project payroll system. Then semi-detached projects. Medium complexity, teams have mixed experience. Example, inventory management system. See, first one is organic projects, means small and simple projects with experienced team. Okay, example, a student project or payroll system. Okay, second is semi-detached projects means medium complexity, where the team has mixed levels of experience. Example is an inventory management system. Okay. Third is embedded projects, means large complex projects with strict hardware and software requirements. Example is like defense software or medical systems or medical software. Okay. Then levels of COCOMO model. Okay, there are three levels of COCOMO. Basic COCOMO gives a quick estimate of effort and time using size LOC. Simple formula. Intermediate COCOMO considers cost drivers like hardware, personal tools, etc. More accurate than basic C. See, COCOMO has basic three levels of estimation. Okay, first one is basic COCOMO, gives a quick and rough estimate using only size in LOC. Okay, then intermediate COCOMO, more accurate because it also includes cost drivers like hardware, personal and tools. Okay, third is detailed COCOMO, the most advanced level. It considers all cost drivers and calculates effort for each development phase separately like design, coding and testing. Okay. Then advantages of COCOMO. First is it provides a scientific way of estimation. Provides scientific estimation. See. Then it helps in budgeting and project planning. Then it reduces the risk of overestimation or underestimation. Okay. Then it's easy to understand and apply. Okay. Then we can see limitation of COCOMO. See, it depends on lines of code LOC, which is hard to predict in early stages. Okay, so the constants may not fit every modern project, and it is less effective for agile or iterative development models. Okay, conclusion. See, to summarize, the COCOMO model is one of the most important methods for software cost estimation. Okay, like it gives a structured and mathematical approach to calculate effort, cost and time. Okay, even though it has some limitation, it is still a foundation for many modern estimation techniques. Okay, that's all for today's deep dive on the COCOMO model in software engineering. Thank you.